All right, so this is 9.5 day 3, which is complex numbers in Demoivre's theorem. These notes start with an opener. So you can go ahead and pause the video and try the opener yourself, and then just fast forward through to check your answers, or if you need help with these, you can watch this part. All right, so this says find the polar coordinate given this rectangular coordinate, and it wants r values greater than or equal to 0 and the theta value between 0 and 2 pi. So remember that means that our angle is going to be in radians when we're finding this. Okay, so realize we have x and y, and we need r and theta. So if we have x and y and we need r, we use our equation, our converting equation, x squared plus y squared equals r squared. So we have negative 4 root 3 squared plus 4 squared equals r squared. Negative 4 root 3 squared, as a reminder, is negative 4 root 3 times negative 4 root 3. And negative 4 times negative 4 is 16. And root 3 times root 3, well, it didn't change colors, but whatever, is root 3 times root 3 is 3. 16 times 3 is 48. So this is 48 plus 16 equals r squared. 64 equals r squared, and then squared to solve. Remember when we squared to solve, we account for both the positive and the negative answer. That would make r squared 64. But if you look at the directions here, we only want positive r values. So I'm going to say r is 8. Okay, now we need theta. So remember, if we have x and y and we need theta, we could always use the equation tangent of theta is equal to y over x. So we have tangent of theta is equal to my y value, which is 4, over my x value, which is negative 4/3. The 4's cancel, or simplify to 1 is what I should say. You still have a 1 up here. And now I need to rationalize. So to rationalize, I'm going to multiply by root 3 over root 3, and I get tangent of theta is equal to negative root 3 over 3. All right, so now remember, I need to find the angle that has a tangent of negative root 3 over 3. There's 2 angles in the unit circle that have this as a tangent, but we're only looking for one of our angles. So which one is it? We are going to use our point for help on that. So if we were to graph the point negative 4 root 3, comma 4, we would go left and up. So this is our angle in the second quadrant. So if we want to know that angle, we have to first know our reference angle. So we need to know the angle in the first quadrant that has a tangent of root 3 over 3, which is 30 degrees, which is pi over 6. So pi over 6 is our rough angle, but not our actual angle. So now to get our actual angle, second quadrant right here is 5 pi over 6. So theta is actually 5 pi over 6. All right, now we can write our answer. Remember, this is a rectangular coordinate, and we're converting it to a polar coordinate. So our answer should be an ordered pair, r comma theta. So that's 8 comma 5 pi over 6. All right, next part, write the complex number in polar form. So this is a rectangular number, and we're converting it to polar form. So we could use these exact same equations because we have an x and a y value and we need r. And we have an x and a y value and we need theta. So could we use the exact formulas above? Yes, but there's another way to do it too. So I'm going to show you both. So as a reminder, what you could do is plot this point first to see where it's at. This is taking care of that second part of knowing where the angle is. So this is root 3, which is positive root 3 to the right, down 1. So I'm in the fourth quadrant, and I can connect it to that the origin to that point, turn this into a right triangle. Then I can say this is over root 3 and down 1. Then I can find r using the adjusted Pythagorean theorem, already solve for r. So notice this takes care of doing the plus or minus part because we know we're only going to use the positive answer. All right, x value is root 3, so root 3 squared plus negative 1 squared. I get r is equal to the square root of 3 plus 1. That's r is equal to root 4, so r is 2. So notice it's the same work as above. Either formula is fine. Now I need theta. Please remember that theta is from the positive x-axis counterclockwise until you hit that terminal side there. So that's theta right there. So what we can do is we can find alpha right here, and that's what I could have called this angle up here, is called it alpha, and then found theta. Same idea. We're going to find alpha, and we can use, anyway, I can put the 2 right here too, and we can use whatever you want. We could use tangent and do opposite over adjacent, do -1 over root 3, rationalize it very similar to the one above, or you can use two numbers that you'd rather use, like -1 and 2. That's what I'm going to use. So I'm going to say opposite and hypotenuse. I'm going to use sine instead of tangent. So I'm going to do sine of alpha is equal to opposite, which is -1, over hypotenuse, which is 2. So now I'm going to get alpha, which is our reference angle. The angle that has a sine of 1/2 in the first quadrant is 30 degrees, which is pi over 6. So this is a pi over 6 ref angle again. But we need theta, and theta is this angle right here. So I need my angle in the fourth quadrant. That's my pi over 6 angle. So remember, our pi over 6 angles go 1 pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. And I didn't read the directions. I just realized it says in degrees. So I don't even need to do this in radians. So let's go back and say 30-degree reference angle instead. So now I need my 30-degree reference angle in my fourth quadrant, which is 330 degrees. If it was in radians, it'd be 11 pi over 6, which I already accidentally explained. So now I can write my answer. This is not a coordinate. So you are not writing it as an ordered pair. It is a number. So we are writing it as a complex number. You can write it in cis form, or you can write it the long way. So there's two ways you can write your answer. You can write 2 cosine of 330 degrees plus, I don't like how I made my plus sign there, plus I sine of 330 degrees. That is one way to write your number. Or you can write it in cis form, which I like to write better because it's just easier. So, or you can write 2 cis, which remember means cosine plus I sine of 330. So either one of those is fine. All right, and if it was radians, it'd be 11 pi over 6. All right, next warm up, identify each as a line, a circle, a cardioid, a rose, a limacone with a loop, or a limacone without a loop. All right, so looking at the first one right here, we have an n value in front of theta, so that makes this a rose. If you look at the next one right here, where it's in the form of 1 plus or minus, or I should say a plus or minus a sine, these two values are the same, so that is going to make it a cardioid. Next one right here looks very similar to the other one, but if you notice, these two numbers are different numbers. So since those two numbers are different numbers, this makes this a limacone. Now I need to know if it's with a loop or without a loop. So now we're going to compare A to big. A is less than B, so that is with a loop. A is less than B, loop. All right, looking at this, same idea here. This is going to be a limacone again because we have two different numbers there for A and B. So limacone, now you know if it's with or without a loop. A is greater than B, so A is not less than B, so this is no loop or without a loop. All right, next one right here, we have R sine. Remember, R sine is the same thing as Y, so this is like Y equals -1, so this is a line. Next one, theta equals are all lines. Next one, R equals 2. That's a circle. And the last one, R equals 3 cosine of theta. This is a circle. Notice there is no, well, there's a value of 1 in front of theta. That automatically makes it a circle. Okay, let's get on to the new material. So what we're doing today is we are taking roots of complex polar numbers. So we're taking roots of complex polar numbers. So our imaginary numbers that are polar numbers, and then we are going to take the root of that. So here is how we take the roots. So if you have, we're calling our polar numbers Z, remember, and you want to take the third root, let's say, we'll call it that K, okay? Well, actually, no, Z sub K is, we're using K down here because we're going to take multiple roots. So if you are taking the cube root of a polar number, there are going to be 3 roots. And you're going to end up find all 3 of them. And that's what your K values are going to be. Okay, So what you're going to do, if you want the 6th root, 5th root, 4th root, whatever, that's cube root, you're going to take the nth root of that r value. So cube root of that r value, 4th root, 5th root, whatever. Then you're going to do cosine of, you're going to take theta and you're going to divide it by that value. So if it's cube root, it'd be 3, 4th root, it'd be 4, so on and so forth, plus 360k divided by that value too, that number of root. Okay, this is going to give us our multiple roots. And then we have plus I sine of, the same thing. So theta divided by n plus 360k divided by n. And once again, that 360k will give us our multiple roots. So if there's a cube root, it'll end up what's giving us our 3 roots. Also, I want you to realize that this is derived from Demoivre's theorem, because if you recall, if I had the square root, that can be written as the 1/2 power. So this would be taking r to the 1/2 power, the 1/nth power, and then we have cosine of, and then remember, you're just multiplying theta by n. Or sorry, you're multiplying theta by this exponent right here, which is 1 over n. That's where the 0 over theta comes from. So it is derived from Demoivre's theorem. Okay, so, oh, I forgot to say one thing. I put 360k right here, but if it's in radians, okay, so if it's in radians, you're going to use 2 pi k over n if in radians. Okay, now we can go ahead and get started with my long explanation. All right, so this says express your answers in polar form with arguments in degrees. So we don't have to worry about that 2 pi k. All right, find all complex third roots or cube roots of this polar number. So I'm going to start by saying z sub k, okay? Because I say k because I'm going to end up plugging in and getting 3. I'm going to plug in 0, 1, and 2 to get my 3 complex roots. I'll explain that when we get farther into this. All right, so you are going to take the nth root. So n is 3. You're going to take the cube root of r. Remember, r is 5 and this is theta. So you're going to take the cube root of 5, and then you're going to do cosine of theta, which is 120, divided by n, which is 3, plus 360k divided by n, which is 3, plus I sine of the same thing. You write that out, 360k divided by 3, close it, close it. All right, now you're going to clean this up. Okay, so now you're going to clean this up. Do we know the cube root of 5? No. Can we simplify it? No. It's just 5 to the 1/3 power, but still we can just keep it as cube root of 5. If it was cube root of 8 or cube root of 27, cube root of 64, we would change it. All right, so now we have cosine of, and we're going to simplify both of these fractions. 120 divided by 3 is 40 degrees, plus 360 divided by 3. I do 3 divided by 3 is 1, 6 divided by 3 is 2, 0 divided by 3 is 0 to get my 120 if I didn't know that already. So 120 degrees K plus I sine of, and then you don't have to do the math again. It's the same, 40 degrees plus 120 degrees K. All right, so this isn't your final answer, but this is going to give you your 3 final answers because there's 3 cube roots. So you're going to always start with z sub 0, and then you're going to have z sub 1 and z sub 2 because you have 3 cube roots. So it's always, so if I was finding 5 roots, I'd plug in z sub 0 through z sub 4. All right, so let's start out by plugging in 0, 4, k. You're plugging it in here and here. We can write this in cis form. So I'm going to write the cube root of 5 cis, and now I just have to get theta. So if I plug in 0 right here, 120 times 0 is 0, plus 40 is 40 degrees. So there's my first root. Then I have the cube root of 5 cis. Now I have to plug in 1 here, okay? 1 times 120 is 120, plus 40 is 160. And then cube root of 5 cis. And then plug in 2. 2 times 120 is 240, plus 40 is 280. So I showed you the longer way of getting the next 2 answers. If you notice, this goes up by 120, up by 120. So you can just get the next 2 angles just by adding this number to each of the additional ones. All right, so there's my 3 complex roots. All right, let's try another one here. So this one says find all the 4th complex roots of z equals root 3 minus 1. So remember, in order to do this, you need z, r, and theta. If you look at this, I have z, x, and y because I have a rectangular number. So I need to first convert this to polar form. So let's go ahead and convert this to polar form. I'm going to go off to the side and plot it and get r and theta. All right, so this is root 3 minus I. So I go right root 3 down 1, and I have, here is my right triangle. This is root 3. This is -1. Now this might seem familiar. It's from the warm-up, okay? So if you didn't watch the warm-up, you could go back and watch the warm-up and see what I got for r and what I got for theta, but it's the exact same problem, so I'm not going to do it again. So you end up I'll go back up here. In fact, you know what? I'm just going to copy and paste it. All right, so watch this. Watch me go. Copy. There's all my work for it. And if you need to see the work because you fast forwarded through that part because you're like, I don't need to do that, go ahead and look at it. All right, so there is my work to find r and theta. So I know r is 2, theta is 30, and I know that n is 4. Okay. All right. So I could write this as 2 cis 330 right now, but I don't need to. All right. So now let's find our 4 fourth roots. So I have z sub k equals, and now I'm going to take the 4th root of r. So here's r, which is 2, 4th root of 2. Cosine of, I need my angle, which is 330 degrees, divided by my n value, which is 4. Plus I sine of 360k divided by 4. I'm sorry, I wrote that wrong. Delete, I wrote that wrong. I already put the I sine of in there, so let's delete that. Got ahead of myself. Plus 360k divided by 4. Plus I sine of the same thing. Plus I sine of 330 divided by 4 plus 360k divided by 4. A little scrunched, but it's okay. All right, so now I got to see if I can clean this up. So 4th root of 2, I do not know, and I ask myself if I can simplify it. That's 2 to the 1/4 power, which, nope, can't do anything with that. So now I'm going to find my 4 complex roots. Z sub 0, Z sub 1, Z sub 2, and Z sub 3. 4th complex roots. All right, so I'm going to start by plugging in 0. So I have 4th root of 2, cis. If I plug in 0, 4k. Now, I didn't simplify my fractions yet. I'm going to go through and simplify my fractions first so that it makes it easier on me. So I have 4th root of 2, cosine of, all right, so 330 divided by 4. There's 2 ways to do this in your head because you're not allowed to use a calculator. You can divide by 2, divide by 2. So 330 divided by 2 is 165. 165 divided by 2 is 82.5. You can do long division, or you can do the method that I use, which is long division, but I just don't write it out long. So I say, how many times does 4 go into 33 without going over? It goes in there 8 times. So I say, okay, well, what's the remainder? Because 8 times 4 is 32, so that means there's a remainder of 1. So now I'm going to put a 1 right here, and then I'm going to do 10 divided by 4. 4 goes into 10 twice, and there's a remainder of 2. So I still have 2/4 left, which is 0.5, 82.5 degrees. Plus, and then simplify 360 over 4. So 36 divided by 4 is 9. 0 divided by 4 is 0, so 90k. Plus I sine of, the same thing. 82.5 plus 90k, 90 degrees, k. All right, now we can plug in 0. So if I plug in 0 here, I get 82.5 degrees. 4th root of 2 cis. Now remember, I'm plugging in 1, so I'm adding 90, and then I'm going to add 90 again, add 90, add 90. The easiest way to add 90 in your head is to add 100 and subtract 10, or at least that's what I think. So if I add 100 to this, I get 182.5. So if I subtract 10, I get 172.5. See that? 4th root of 2 cis. Add 100, 272. Subtract 10, 262. Add 100, wait, let me write this part down. Add 100, that's 362, so this is 352.5. You should never go over 360 degrees. It'll never happen unless you made a mistake. All right, so let's move on to the next one here. So this is find the complex third root where z is equal to -8. Once again, -8 is not in polar form, so we want to get r and theta. We have n already, so let's get r and theta. So I'm going to do a sketch. I'll do it off to this right here. I'm going to do a sketch off to the side so I can get r and theta. So I need to graph the value of -8. So I'm going left 8, and then there is no imaginary part, so I'm not going up and down. So there is the point right there. So I need r first. I can't make that into a triangle, but remember, r is the distance from that point to the origin. So what's the distance from that point to the origin? 8. Right, positive 8 because distance positive. And now I need theta. Theta is the angle made by the positive x-axis going counterclockwise until you hit that terminal side. So that is 180 degrees. Could I put pi if I wanted? Yes, but I work better in degrees. And I'm converting, so... the directions say I want degrees anyway, so let's keep it at 180. Okay, so now I have r, theta, n. We can find the nth roots. So we're going to do z sub k equals, I need the cube root of r, which is 8. And then we have cosine of my angle, which is 180, divided by n, which is 3, plus 360k divided by 3, plus I sine of the same thing. 180 divided by 3 plus 360k divided by 3. All right, let's go ahead and simplify this before we plug in 0, 1, 2, and 0, 1, and 2. All right, so cube root of 8 we do know. Cube root of 8 is 2, and then we have cosine of 180 divided by 3 is 60 degrees. 360 divided by k is 120 degrees k, plus I sine of the same thing. So easier mental math with this one. All right, so now we're going to find our 3 complex roots. Z sub 0, Z sub 1, and Z sub 2. All right, plug in 0, and I get 2 cis 60 degrees. Plug in 1 or add 120 to that, 2 cis 180 degrees. 2 cis, either plug in 2 or add 120 to your last answer, and I get 300 degrees. And there's my 3 polar complex numbers. Complex roots. Okay, last one. Find all the complex 4th roots of, and then there's my number that's not polar once again. So I need to convert it to a polar number, and then I can take the nth roots. So let's once again off to the side, find r and theta. We already have n. So this is n, and we need r and theta. So this is left and down. So I'm going to go left and down and make my triangle here. All right, so it's left -1/2 and down -√3 over 2. All right, so I'm going to use my modified Pythagorean theorem to find r. So I have r equals the square root of x squared, which is -1/2 squared, plus y squared, -√3 over 2 squared. R equals, remember to square a fraction, you square the numerator and you square the denominator. So -1 squared is +1, 2 squared is 4, so that's a 4th, plus -√3 is squared is √3, plus 2 squared is 4. So I have r equals the square root of 1/4 plus 3/4 is 1. So I get r is 1. So it looked like it was going to be awful, and that wasn't bad. So we have r is 1. Now I need theta. Remember, this is not theta. We're going to call it alpha, and then we'll use that to find theta. So you can pick whichever two you want. I'm going to choose the 1 and the -1/2 because it looks like it's going to be the easiest for me. Could I use the 2 that I have? Of course. All right, or sorry, the 2 that I was given, of course, but I like the 1 better. So that is adjacent and hypotenuse. So I'm going to do cosine of alpha is equal to the adjacent side, which is -1/2, over the hypotenuse, which is 1. If you simplify that fraction, it's just -1/2. So a lot easier than I thought it was going to be, right? All right, so I need to know the angle in the first quadrant. This is how I talk to myself, right? The angle in the first quadrant that has a cosine of 1/2, or an x value of 1/2, is 60 degrees. So this is a 60-degree reference angle, okay? But it's not in the first quadrant, so I need to know the 60-degree reference angle in my third quadrant, which is 240 degrees. And if you forgot what it was, you can say, all right, well, I know this is 60. 180 plus 60 is 240. See that? Okay, so now we know theta, we know r, we know n. We can find the four complex fourth roots. So we're going to do z sub k is equal to, we're doing the fourth root of r, which is 1, cosine of angle 240 divided by n, which is 4, plus 360k divided by n, which is 4, plus I sine of, the same thing, 240 divided by 4, plus 360k divided by 4. All right, simplify those fractions and simplify the fourth root of 1. Fourth root of 1 is what number multiplies by itself 4 times to give you 1, and that is 1. So we're just going to write it as 1. And then we have cosine of 240 divided by 4. 24 divided by 4 is 6, and then 0 divided by 4 is 0, so 60. Plus 360 divided by 4 is 90k. 360k divided by 4. Plus I sine of, the same thing. 60 degrees plus 90 degrees k. And now I can find my 4 complex roots. Fourth, yes. Z sub 0, Z sub 1, Z sub 2, and Z sub 3. Notice there's 4 totals. You're not plugging in Z sub 4. All right, so I have 1 cis, and then my angle when I plug in 0 is 60 degrees. 1 cis, adds 90 to that, and I get 150, or plug in 1 and you get 150. 1 cis, 240, 1 cis, 330. And there's my 4 complex roots. People always ask you have to write the 1. If you're writing in cis form, absolutely. If you were writing the long way, where you were writing 1 cosine of 60 plus I sine of 60, you wouldn't need the 1 here because it implies that there's a 1 there, but when you're writing in cis form, you want the 1 in front. All right, that's it for today.